red team, aka Team Ares, that is Aerospace Rocketry Engineering Systems. And our team was responsible for getting there and back, which is to say we were responsible for getting everything necessary for the mission to Mars and then bringing the crew home from Mars after the mission. To accomplish this, we split that large task into 3 subtasks: launch and landing, which I'll be talking about; ship design, which Greg will be talking about; and life support, which Wyatt will be talking about. So launch and landing is probably one of the largest things our team is responsible for. And to do this, we split the mission into 2 phases. First is a launch of unmanned supply craft to Mars, carrying supplies that the crew will use once they arrive, and also equipment that will begin to autonomously construct parts of the colony. And then phase 2 of the mission, the manned phase, starts in lunar orbit where the spacecraft will be constructed, after which we'll launch out of lunar orbit into Martian orbit, where it will remain while the crew works on the surface. And then at the end of the mission, it will launch away from Mars back to Earth. So the mission actually begins in 2030 with the construction of the Crew Transport Craft, or CTC, and this will be constructed in lunar orbit because of the sheer size. It actually is easier to construct it in lunar orbit than it would be to launch payloads of that mass from Earth. And while that is being constructed, the 2 unmanned supply craft will launch from Earth directly to Mars, as I said, carrying supplies that the crew will use once they arrive, and also equipment that will begin to construct the colony autonomously. And finally, once the CTC is complete, the 16 crew members will board the craft and will boost out of lunar orbit to Mars. And upon their arrival, they will enter 2 landing craft, which will land near the 2 supply craft, at which point the colony can begin operation. Now, jumping forward, 1 month before the end of the crew's stay on the Martian surface, 8 of the crew members will enter one of the landers and rejoin the CTC in orbit, and they will begin powering up systems, running checks, and performing any maintenance that will be necessary to prepare the CTC for the 6-month trip back to Earth. And 1 month later, after the end of the stay, the rest of the crew will return to the CTC, at which point it will boost back to Earth. And while the CTC is in transit, 2 Earth return capsules will launch and enter Earth orbit, and upon the CTC's arrival, they will rendezvous, pick up the crew, and they will then re-enter Earth's atmosphere and perform a splashdown very similar to those performed by the Apollo program. And now to talk about spacecraft design is Greg Shea.
Hi, I'm Greg Shea, and I'm going to tell you about the ship design needed for the ships to traverse the immense distance between Earth and Mars. First, there are the 2 robotic supply craft, which are unique because of their unprecedented cargo capacity, the low energy transfer that they complete, and their ability to transport fuel from the Martian surface to the CTC. Second is the Crew Transport Craft, which has new ideas implemented in a propulsion system, an artificial gravity system, and the power systems that are aboard. First are the robotic supply craft. Each will be able to carry 25 metric tons, and this immense mass is needed because of the duration and scope of the mission to Mars, and this will carry supplies for both the living there and working there teams. And because neither of these robotic craft have any human passengers, they can take a low energy transfer, which is far more efficient and takes more time. But because there are no human passengers, there is no need for a quick transfer. Upon landing upon Mars, and when the water production facilities are set up, these supply craft will automatically ferry water back to the orbiting CTC, and this is used to refuel the CTC for the return journey. And right here is the basic design of the crew transport craft. As I mentioned, the water is ferried to the crew transport craft, and towards the back of the craft, you can see the engine bells of the nuclear fission engine. The nuclear fission engine uses water as fuel by superheating the water to the point of explosive expansion, and then this is ejected through the engine bells and provides thrust for the craft. At the front of the vessel is the artificial gravity system, which consists of a rotating centrifuge used to simulate Earth's gravitational field. And at the start of the mission, this rotates at a rate such that Earth's gravitational field is simulated, but over the course of the voyage, this slows down, and by the end of the mission, simulates Mars's gravitational field, acclimating the astronauts to the Martian environment before they ever set foot on Mars. And at the middle and the rear of the spacecraft are the solar arrays and the nuclear generator, which power all of the systems aboard the spacecraft during the transit. And the solar arrays gimbal in order to constantly maintain the best angle for solar absorption, retaining maximum efficiency. And here is Wyatt Curtis to tell you about the safety hazards.
Hi, I'm Wyatt, and I'll be talking about the safety hazards aboard the ship to and from Mars. So there are many hazards that come into play when you're traveling that far into space, such as radiation from cosmic rays, body deterioration from a lack of gravity, and external impact from things such as meteorites. Also, there are several life support systems we will be implementing on the ship, such as an environmental control system, which will take Earth's gravity and not gravity, but environment, and simulate it on the ship. Water and waste removal, which will supply needs and keep the ship clean, and automation aboard the ship. So, radiation. To deal with this, we are filtering water through an insulation system on the outside of the ship that will block almost all of the radiation that's trying to penetrate through the ship. And for body deterioration, Earth's gravity is being simulated on the ship through the spinning centrifuge, but there will also be a workout facility that will require mandatory workouts for each astronaut to ensure that their bodies stay intact and together. Well, not together, but for external impact, we're using a long-range radar to predict where big meteor showers could be, and tiny thrusters that could alter the course of the ship and recorrect it with the ship's automation system. So the environmental control system will use a system of photoionization detectors and oxygen monitoring to keep ammonia out of the air and keep oxygen at safe levels so everyone can breathe and be happy. Water and waste removal will recycle 100% of the water, even from human waste, much like the International Space Station. But it's not as dirty as you would think. It's actually cleaner than the water we have here on Earth. And solid debris will be ejected away out of the solar system. And lastly, an automation system will be implemented that will allow the ship to operate by itself so crew members can conduct scientific experiments and have some recreational time on the flight there. Thank you. We're red team getting there and back.